All right, so here we have an example of a series, and we want to determine if it converges absolutely, conditionally, or if it diverges. So first thing you always want to do is to apply the absolute convergence test. Because if it converges absolutely, then there's no need to test for conditional convergence. So let's go ahead and do that. So I'm going to go ahead and apply absolute value in my series. So you have the sum starting from 1 to infinity, absolute value of -1 to the n, sine of n over n squared. And when you take the absolute value of this sequence, an, -1 to the n will drop out. So you're really looking at just the sum starting from 1 to infinity of sine n over n squared. Well, what is this going to do? Will this converge or diverge? So I know I can do some comparison here. So we know that sine of n, well, sine is always bounded between 1 and -1. Since we're not looking at the negative values for n, so I'm going to say it's greater than 0. And then we divide each side by n squared, like that. So we can do the comparison with 1 over n squared. So we can say that this sum is less than or equal to, so this is the inequality we came up with. So we can say this is less than or equal to the sum starting from 1 to infinity of 1 over n squared. Now, what can you say about this series right here? Well, that's a p series, with p being the power of n is 2. So if p is greater than 1, we know that that series converges. So we can conclude that this series converges, which means since this is below the one we're looking at, this is going to converge as well. So we can say that by a comparison test, this series, and starting from 1 to infinity of -1 to the n sine of n over n squared converges absolutely. Because when you took the absolute value, it turned into sine of n over n squared, and we compare that with 1 over n squared, that's a p series, converges. So sine of n over n squared converges, which means the one we're looking at, which has the alternation, will converge absolutely. Now, if you didn't want to test for absolute convergence and you want to look at the same question from different perspective, you can apply the alternating series test. So let me show you that as well. But that's not important in this question, since we already know it converges absolutely, which implies it will converge conditionally as well. But let's just illustrate that. Why not? So we're going to apply the alternating series test for this same series into infinity of -1 to the n sine of n over n squared. Now keep in mind, this is optional. You don't have to do this, but we're going to apply it just in case you wanted to see how it's done. So for the alternating series test, there are 3 conditions you want to make sure. The first condition is your sequence, which is right here. Let's call that un. You want that to be always positive, meaning the terms without the negative, they're positive. And sure they are, when you plug in n equals 1, 2, 3, and so on, they're always positive. The second condition you want to make sure is that your sequence is decreasing, meaning they're going down. So if you compare your u sub n plus 1 term, the u sub n plus 1 term, that's going to be less than u sub 1. So that's going to be less than the previous term. And you can check that with this guy right here. If you plug in n plus 1 with n, you will see that that's a decreasing sequence. So this is also checked. And the last thing you want to check is that the limit as n approaches infinity of this sequence goes to 0. Well, let's check. So if I take the limit as n goes to infinity of sine of n over n squared. So n squared is growing much faster than sine n, because sine is bounded by -1 and 1. So this limit will be 0. So there you go. All 3 conditions are checked, which means by alternating series test, we know that this sum starting from 1 to infinity of -1 to the n sine of n over n squared converges conditionally. Well, I don't really want to say that. I'll say converges by the alternating series test. Of course, this is a conditional convergent test, but we know that we have a stronger statement from before that it also converges absolutely. So that's the test you always want to apply first. And then if it diverges, then you can test for alternating series test.